IR 1.8. So let me read it. Two boats, write down, two boats A and B move away from a buoy anchored us at the middle of the river. BUOY. Buoy means some kind of a what we call open buoy or buoy, whatever some people pronounce it like that. Okay, so it is in the middle of the, it's anchored in the river, in the middle of the river. Okay, so let us say two boats actually go away from that. Okay, anchored at the middle of the river along the mutually perpendicular straight lines. So two boats A and B move away from a buoy anchored at the middle of the river along the mutually perpendicular straight lines. Along the mutually perpendicular straight lines. Okay. The boat A along the river and the boat B across the river. And having moved off an equal distance from the buoy, the boats returned. Full stop. Find the ratio of times of motion of boats T1 by T2 if the velocity of the boat, sorry, T1 by T2, TA by TB, because they call it as A and B, no? It is TA by TB. Okay. If the velocity of the boat with respect to water is n is equal to 1.2 times that of the stream velocity. 1.2 times that of the stream velocity. So please read the question on your own once and see whether you can first of all imagine the question. If you see them, they are saying that there is a river. Okay, assume that this is my river. So moving like this. This is my river. Okay, in this river, in between, let us say your buoy is anchored. Okay, so now from here, the boat A will go along the river like this for some distance. Okay, whatever distance, and it will come back now. Okay, and boat B, this is A, boat B will go perpendicular to the river for the exactly same distance, and it will come back. But obviously, the both will take different amount of time. Say it. No, that is the question. You have to understand that question. Read the question properly. He says that they actually travel exactly orthogonally, one across, one along, and reach certain distance, come back. But to be able to go so, okay, they actually would have started like this. Only when they start like this, they can go like this. Correct? They are trying to go this way and manage this. So that is how it happens. When you are going in a stream, if you want to reach this point, if it is flowing like this, you swim this way so that it will come here. So the clue is that if this is the velocity vector of the if this is the velocity vector of the boat B, okay, VB, and if this is the velocity vector V naught of the stream, then the velocity, resultant velocity is this. Correct? Because VB plus V naught is the resultant velocity. Triangle law. We know VB. Okay. That means basically as on its own we know. Without actually, with respect to V naught actually means if you make the river stand still, then what would be the VB that we know. So this one actually, you see here what is happening here. Here, VA is in this direction. Okay, let me just write it properly here. It has gone here and come back. Okay, so VA is in this direction. Okay, and that VA is actually is equal to VB. Okay. But while going, it gets added to the stream velocity. Its effective velocity is nothing but VA plus V naught. Okay, so it is in the same direction. It easily gets added. Here it is vectorially added. Here also it is vector, but in the same line. And coming back, it will be what? So here you see, while going, it went like this. Okay, tried to go like this, and went in this direction and reached here. So while coming, it has to try to go which direction? Should it go this way or should it go this way? Correct. It has to go like this. Okay, and this is again VB, and this is again V naught, and this one is the coming back vector. So now you can start calculating. You know a lot of information now. Calculate TA, calculate TB, and divide each other. So let me actually show you. So we have to calculate TA and TB now. TA. So time is nothing but distance divided by velocity. Okay, that we know. Okay. So TA, I will take it as basically TA going plus TA coming. Going time and coming time. I'll add that. Okay. So going time, how much we'll see. Okay. So let us say the distance we will take it as D. Okay. D divided by, okay. So I will take VA is equal to VB is equal to V is equal to N V naught. Okay. We will take it as basically V plus V naught. While going, it is V plus V naught velocity. Okay. Plus, while coming, D divided by V minus V naught. Okay. So that is basically our TA. So we will do a little bit of more addition on this. Okay. V plus V naught into V minus V naught, which is basically V square plus V minus V naught square. Okay, and the numerator will have D into V minus V naught minus D into V plus V naught. Sorry, plus. So which actually removes for us V naught, D into V naught and D into V naught will go. So 2D into V will remain. V square minus V naught square. This is what this is TA. Okay. Let's calculate TB, which is equal to again going time plus coming time. TB going plus TB coming. Okay. So now, so what is TB going? Again, it is distance is d only. There is no difference. Okay. So if you look at this is the effective velocity. This length is equal to VB square minus V naught square under root. This length by Pythagoras theorem. Okay. So we will take this length as basically V square minus V naught square under root. So similarly, plus while coming back, d divided by, here also you see this is the distance, this is the velocity. This velocity is nothing but Vb square minus V naught square, okay, under root. Which is equal to 2d divided by square root of V square minus V naught square. In this case, going and coming has the same amount of time, no? It takes, because it is the same problem. Sidewise it is pushing. Now TA by TB you calculate now. So TA divided by TEB, 2D gets cancelled. Okay. So V divided by V square minus V naught square divided by 1 by V square minus V naught square, okay, which is nothing but 1 by V square minus V naught square under root. Which is V is nothing but n into V naught. N into V naught whole square minus V naught square. So is there anything that I did a mistake? Huh? Correct. So this is nothing but n into V naught. Okay. So that is nothing but so that V naught will come outside and get cancelled and all. So answer basically is n divided by square root of n square minus 1. So which is nothing but 1.2 divided by square root of 1.2 square minus 1, which is nothing but 1.8. Okay, so this problem is actually giving you some every problem when we do, whatever the wisdom you get out of that, you have to absorb it. Okay, like when you are talking about vectors here, we have actually kind of used vector addition here. Okay, so to get the resultant velocity, that is the only thing which is new here.